Okay, so we have a bunch of equations that are in the notes and maybe written down. They're important and they give you these friction factors. So now I just want to describe to you what this Moody chart is. And that's kind of a big part of the class, at least when I took it. So you could say, I guess the one different thing I'm doing is I'm not putting a big importance on this Moody chart because it's a chart. So maybe we used charts back in the 70s or 50s or 60s when we hand drew a bunch of things, but we have a bunch of fast working computers. So it kind of bugged me that I wasted a bunch of time looking at this chart. But there are some PE problems that ask you to like find a number in these Moody charts, so I have to tell you how to do that, as much as it burns my soul. Okay, so this is point right here. This is a log scale right here, log scale right here. So this is the friction factor. And then what we do is you get this classic graph where this linear log section right here is the laminar. And then you get this sort of transition region where a bunch of stuff happens. And then you get a bunch of lines sort of looking like this. Kind of doing things like this. And then you have this fully rough sort of line. That's like fully rough is the sense that it's fully rough being like when that roughness factor is very, very large. Okay, and then each of these values, right, is a specific epsilon over delta value. So this is like, this is for and that is for epsilon over delta increasing. And then you have this, something called the fully rough regime, and that's when this epsilon over delta is just enormously large, like too big, like almost comparable to the diameter, that's like that rough. And then these are a bunch of separate epsilon over delta. So what are the processes to figure out these? What are the processes to figure out your friction factors? This chart actually can get you the laminar and it can get you the turbulent. You just kind of have to know how to do it. So for any problem you have, obviously calculate your Reynolds number. So you have a flow type problem, you're going to have to calculate Reynolds. Step one, calculate Reynolds number for the pipe flow problem. Find that point on this graph, right? So it's here, it could be here. You could don't interpolate. It's a log scale, so it'd be kind of weird, but just kind of get in the area if it is. Next is you got to determine your roughness height. So that's look up a table, right? So, right. Find the roughness height material. And that's a table in the book. I put one in the homework as well, but that's the process. Step one, get your Reynolds number. Now get your roughness height. Find what line you kind of lie on in here. If you're not in between, just pick the rougher value. Don't interpolate for a graph, for God's sakes. But just pick the rougher value because that's a conservative estimate. So get that roughness. If you don't totally lie on one of these, get the closest you can get to these values. Now that you're on here, connect these two lines. So go here, go to Reynolds number, now go up, get to this point right here. So let's say I was on this line, I go to Reynolds number, I found it, it's right here. I go up, 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 up. I go here, and I go, what's my friction factor? I go up, 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 up. That's your friction factor. That's how you use a Moody chart. Or you use an Excel chart and you just have the computer give you the friction factor. You can put a little Boolean rule in there saying if Reynolds is under 2,000, use that simple formula. If it's bigger, use my crazy one. And you also have a little Boolean that if this thing's too big, use the fully rough. And that's it. So I didn't have this in the notes, but one of the what I'd love, a super good extra credit, I would think, right? make a Moody chart. Make it in Excel, MATLAB, I don't care. You could use Python. If you use Python, I'll give you double points. Do that. And then you would really know how these Moody chart, how to use it, what all the quantities are. You can see this regime right here, this transition of going from to laminar, right? And just make one of these. You'll see all the same things. You will have to pick certain close enough roughness heights, but pick them, right? Pick 10 values of roughness on a very small scale, and then make this. So up next, I'll give you actually some regimes of roughness heights, so you can better make this extra credit, or just get a sense of where do these F numbers lie commonly, and what roughness heights do we usually encounter.